Newton's first law states that an object at rest will remain at rest, and an object in motion will remain in a constant motion unless acted upon by an unbalanced force. Like this ball, all the forces acting on it are balanced, therefore it will not move. This is also because of the ball's inertia. Every object has inertia, and what inertia does is it makes it want to stay in the certain state it is, whether that be moving or not moving. The mass of an object determines an object's inertia. The ball is now being thrown in the air by an unbalanced force. This is why it is moving. And as you will see when I drop the ball, it travels at a constant speed of 10 meters per second squared. That is because of the force of gravity. Newton's second law is a force equals mass multiplied by acceleration. In this case, we are using a softball and a small force to move it. Now we are taking that same softball and applying a larger force. Therefore, the ball travels at a higher acceleration. This is a direct relationship between force and acceleration. Now as you see, we are using a soccer ball. With more mass and the same force being applied to the soccer ball, you will see that the soccer ball doesn't travel as far because when you take the same force and apply it to a bigger object, the acceleration is decreased. This is an inverse relationship between mass and acceleration. Newton's third law says that every action has an equal and opposite reaction. When two objects collide, the same exact force is applied to both objects. It doesn't matter the size, weight, or mass. For example, a bat and a ball. The bat obviously has more mass than the ball. It is much larger and made out of metal, while the softball is much smaller and made out of a material with a much less density. But no matter how hard you hit the ball, and no matter how far the ball travels, they will always give each other the exact same force. But why one object has a greater acceleration goes back to Newton's second law. When two objects of the same mass are accelerated at each other with the same velocity at a constant speed, and it is an elastic collision, both objects travel in the opposite direction at the same speed they started. But when you change the mass of one of those objects, like we did with a soccer ball, the force acting on both objects is the same, but because it is the same force, an object with more mass won't accelerate as much. Circular motion always has an inward force. This is because of centripetal force, which is a center-directed force that makes an object move in a circular motion. When something is being turned by centripetal force and then suddenly released from that force in a frictionless world, an object will travel in the last direction it was going, at a constant speed because of inertia. Think of a car, and when you're in your seat, turning left, you feel a force pushing you right. But it is your seatbelt that stops you from moving in the last direction you were going. Center of mass is a point in an object where the mass distribution is balanced. In many everyday cases, this is the same as the center of gravity. You can find this using a plumb bob or simply your finger. When an object is not hit in the center of mass, the object turns. If an object's center of mass is directly supported beneath it, then it is stable, especially if the center of mass is closer to the ground. If the center of mass is not supported directly below it, then the object is unstable and will likely fall over.